Subnetting simplified. First of all, why do we need subnets? This happens to be one of the main subjects that students, once they see it, they have great difficulty in trying to figure out how it works. And so today, I'm going to show you a very easy way to make it all work. First of all, let's look at why you need it. So let's say if this is represented, these are routers, and let's say that on each side of your network, you had PCs, you had printers, you've got different devices that all need IP addresses. So let's just say that on this side of the network, you needed to have at least 90 IP addresses, 90 hosts that's connected to this network, and let's say that I had 30 hosts that's connected to this network. Now also notice this is a point-to-point connection. This point-to-point connection needs two. Right? You need two IP addresses here, and let's just say that on this side of the network, right, we're going to need 30 and we're going to need 30. Now, here's what I found out, is that once you start looking at binary, most people get really confused about how does it work. So what I like to do is say this much. Don't worry about how it works. What I'm going to do is give you a formula that if you follow this, you don't need a calculator. You can easily solve any of these problems going forward. All right, now, here's the first thing I want to show you, is that this is a very simple chart that every time you want to get, before you start to try to subnet, you write it down. Here's how it works. I'm going to count in binary. 1, 2, 4, 8, 16, 32, 64, 128. And now I'm going to also write down some rules. The rules is this. Networks, if I'm trying to figure out how many networks I'm going to need, and these are hosts, I am going to go networks equals 2 raised to the power of bits borrowed, and that's just it, bits borrowed. Then I got to go host equals 2 raised to the power of bits borrowed minus 2. Now that minus 2 is I'm going to explain that a little bit later on, but let's take a look for now. This is all you have to do is to be able to count in binary. Now, also remember this. I'm going to take 128 and I am going to place 128 above it. I'm going to take 128 and 64 and I'm going to come up with 92. I'm going to take 92 and 32. I'm going to come up with 224. And I'm going to take 224 and 16 and come up with 240, 248, 252, 254, and 255. Here's what I want you to look at and figure this out. Or you don't have to figure it out. Look at this. 128 equals 256. 192 and 64 equals 256. 224 and 2. Okay, do you get the point? Do you understand? This is very simple. Now, all you have to do is understand if I were to turn on all these bits, 1 or 2 or 4 or 8 or 16 or 32, I'm going to end up with 255 total. So, for instance, therefore you always have a maximum of 255. But let's say this, 0 has a value, so we really don't have 255, we have 256. So let's say that I want to do a simple, just solve one of these problems. Let's say I want to have 90 hosts. Right? So what I have to do up here is I have to figure out, if I want to solve 90 hosts, I have to figure out how many bits borrowed minus 2 equals 90. Right? So you could do it one of two ways. I could just count 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64. If I were to add just from 32 to 16, what I would end up with is this value. Trust me. Now, you end up at really 63, but you have to add the 0. So, in other words, if I did this, 0, 0, 0, 0, 0, 0, and this value is going to equal 63, so I have to add another 0, which is going to equal 127 or 128. So I turn that value on. So let's pick an IP address. IP address is this. Let's say we went to our ISP and we had to buy these IP addresses. So we had to figure out how many of these we need to buy in order to satisfy how many networks we had, how many for every host that we want to put on the internet. All right. And so this is what we're working with. Let's just say that we work with 32.0. Now, what we have is we have to subnet in this area. All right. So what I'm going to have is 255, 255, 255, and I have a 0. So this is what I'm getting at. When you have a 255, which is representative of the whole, you cannot change this number. You cannot change this number. You cannot change this number. This was given to you. What you can change is this number. So what we have to do, and if you look at this, if we wanted 90 hosts, this is very simple. I've already solved it. 1, 2, 3, 4, 5, 6, 7. All right. Or a 190, 128. So this is what we have. We have a IP address of 192.168.32.0 with a subnet mask of 128. Or remember this: a subnet. This IP. This is a 32-bit number. This 32-bit number has 8 bits here, 8 bits here, 8 bits here, 8 bits here. So so you have to represent that with this. So if I were to continue this, I'm going to make this a little smaller. Which I could have did this, brought it down. I could have did this 1, 2, 4, 8, 16, 32, 64, 128. I'm going to do the same thing. I'm going to do a 128, 192, 224, 240, 240, 248, 252, 254, 255. Now, you can imagine that, sorry about this continues for another 2 octets. This continues for another 2 octets. So, when we see this number, this is represented in a 32-bit dotted decimal number. So when we see this, we write it as this. And now, just back to this. 1, 2, 4, 8, 16, 32, 64, 128. Same. It's 128, 192, 224, 240, 248, 252, 250, 254, 255. 1, 2. Now, you also know that I don't want to go any further, but we have another. This is the 0 octet. This is the 32-bit octet. This is the 168-bit octet. And this last one is the 192 octet. This is how it's represented. So you notice here, over here, I got 255. Here, I can't change it. I'm adding up every one of these values, 255. 32, I'm adding up all of the values, 255. Now, in the last value, I'm only turning on 1 bit. And what does this bit tells me? This bit tells me that I have a total number of 127 possible IP addresses. Really, I have 128, but you represent 128 by starting with 0 through 127. That's key. 64 is represented by 0 through 63. 16 is represented by 0 through 15. I think you got the point. Is this 0 through 7 and 0 through 3 and so forth. This is what makes it so hard to understand from time to time, is this is how it basically works. So what does this give us? this gives us, this number here with the 128 and the subnet mask gives us an IP address, range of this. Host, 127. Network, the network number is 192.168.32.0. The CIDR, which is how many bits did I have to borrow, how many ones did I have to borrow. Notice that I have 8 over here, I have 8 here, I have 8 here, and I have only 1. So I have 8, 16, 24, 25. So I have 25 ones, and I have a range of IP addresses. My range is going to go from, I'm starting at 0, so my network is 0, my host is going to be 192.168.32.1 through 126. 127 is a broadcast. Sorry about this. Just kind of ran out of space here, but 127 is the broadcast. The next network is this, 32.128. This is the next possible number that could be, is that one. And so now the question becomes, what else do I need to solve? So you can see that this number, 192.168.32.0 WAC 25, would give me 126 hosts, which more than enough solves this problem. I hope that simplified things a little bit. I will continue on with solving the rest of them in another video. Thanks a lot.